Hi everyone, welcome to my first lecture on thermodynamics. Before we go into deeper concepts of thermodynamics, the first basic thing for us to understand is system and surroundings. If you can able to precisely define system and surroundings, you can easily apply the laws of thermodynamics in a much simpler way. If you don't have the clear idea of system and surroundings, later on you may not understand the concept in a perfect way. And if you talk about the history of thermodynamics, the thermodynamics developed those days, where steam engines, IC engines, these are the when they talk about the how much work I can extract from the engines. This is developed by keeping piston and cylinders in their mind, to my knowledge. And in fact, the thermodynamics applies everywhere. It could be mechanical engineers, it could be electrical engineers, it could be chemical engineers. Everywhere the concepts of thermodynamics apply. But in majority of the books, people take the example of piston and cylinder to understand the concepts of thermodynamics. It doesn't mean that only it applies to the piston and cylinder. It applies everywhere. Even a chemical engineering perspective of view, whether the process is feasible or not, whether even electrical engineers, they do apply the concepts of thermodynamics in further. And before the basic one is, if you have the clarity about the system and surrounding, the major portion, the first trick to understand the concept of thermodynamics is you can able to define what is system and what is surroundings. If you talk about this, I have drawn a picture example. A system, it's a consisting, if there is a boundary for the system, and beyond the boundary it is called surroundings. If I club system and surroundings both, if I look both, then it is called universe. This is the basic aspect. And system could be anything. This system I'm talking about, it could be anything. It is the quantity of matter. That means if a certain quantity of matter, 1 kg, 2 kg, 3 kg, any matter that is present inside the system, if you consider that as a system, then that will be your system. Or it is a region in a space. That means there is a space, you have drawn the boundary, then whatever it is happening inside that boundary could be your system. Anything other than this will be your surrounding. System could be, you can see the boundary here. The boundary is not fixed boundary. It could be expanding, it could be contracting. That is called the boundary. The boundary is such a phenomenon which separates the system from the surroundings. Any exchange of matter or energy happens within, you have to, happens around this boundary. Perfect example, what is called fixed system, what is called flow system. If I consider piston and cylinder assembly, you can see here. Before, you can see the piston got expanded. This is before expansion, this is after expansion. If I draw the boundary before the expansion, you can see because of, if I move the piston, suddenly whatever the matter that is there in this piston and cylinder got expanded. You can see the boundary is also got expanded because the mass is fixed here, the boundary got expanded. It's a perfect example of moving boundaries. That means sometimes boundary may be fixed, sometimes boundary may be moving. So this is what the perfect example of a moving boundaries. And second, as I talk about, system is nothing but quantity of matter or region in a space. Let us region in a space. There is a motor which is driving the air compressor. What happens? The air flows in at low pressure, air comes out at high pressure. This is perfect. I have drawn a boundary here, and some amount of, because certain more volume of air is going, less volume of air. After compressor, what it does, it takes higher volume and it make it at a lower volume at high pressures. You can see here, certain quantity of matter is entering, certain quantity of matter is moving out, which is happening around this boundary. That means it's a region in a space. If you consider the air compressor, that is, compressor is my space. Whatever happening inside the compressor, that I have to draw a boundary and see what are the things that are going in, what are the things that are coming out. This is a perfect example of region in a space. System can be fixed, system can be region in a space. That is what the perfect example of the system. And as I said, universe, that means if I consider the system and surrounding, if I put together both, that's called the universe, which is the combination of system plus surroundings. The system can be of three types: open system, closed system, isolated system. Open system means mass can you can see mass can enter. That means a kg of matter can enter into the system, a kg of matter can go out of the system. Energy, that means you can, some joules of energy, this can go into the system, some joules of energies can come out of the system. This is called open system. When I talk about the closed system, mass cannot enter. That means mass means a kg of matter cannot enter into the system, but energy can happen. Perfect example of this. If I heat the piston from the bottom or this boundary, what happens? The fixed mass can expand. Here, no mass is entering the system, only the heat or energy is entering the system. Okay, that is what the perfect example of system. System perfect example is, you can see air is also getting in. That means certain quantity of matter is going into the system, certain quantity of matter is coming out of the system. And second one is, it enters at certain temperature, it exits at certain temperature. If that is the case, that means some heat or energy is going in, some energy is coming out. This is a perfect example of mass and energy. Both are transferring across this boundary. Okay. The last one is isolated system. When you talk about isolated system, no matter and no energy can interchange. That exchange takes place across this boundary. That is called the isolated system. And I have given an example of what is control surface. That means you can see and this is called the control surface. You can see for this air compressor, this is the control surface. Our interest is what is happening across these boundaries. I am not worried about what is happening in it. If matter is coming in, I will point out, okay, 1 kg of matter is going in, 1 kg of matter is coming out, 2 joules of energy is going in, 2 joules of energy is coming out. I am worried. That is what the important stage. And because before we apply the problems of thermodynamics, then how we have to deal with. If you try to solve a problem, thermodynamics is always between the mass and energy. When you deal with the energy, before you attempt any problem, you have to keep in mind, we can deal in terms of total energy. That means total 10 joules of energy is going in. Okay, total 10 joules of energy is coming out. And second way of dealing is energy per unit mass. That means per kg, how much amount of energy is going in. Per kg, how much of energy is coming out. That means you can deal with the per mass. The third way is energy per unit time. How much amount of energy is going every second. Joules per second. How much energy is coming out every second. That means these are the 3 different approaches you solve a problem. In general, the first 2 for the non-flow systems, that means fixed amount of 1 kg's mass is in the system, what is happening with respect to it. That means we deal with 1 and 2, that means joule and joule. Generally non-flow systems. For a flow systems like compressors, okay. Second and third approach, that means energy per unit mass or energy per unit time. So these are the 2 approaches we can solve a problem. Okay, hope you understand what exactly the system and surroundings and how do we have to deal a problems, a different approach. In the next lecture, we are coming with the thermodynamic properties. Once that is done, we move forward to application of first law and second law in solving the problems. Thank you very much. Meet me again.